Hi team, welcome to Wiggins Maths. In this video we're going to be looking at the numerical method of the trapezium rule, which is used to find the area when integrating. So, how would we find the area enclosed between the curve and the x-axis between a and b? Well, we'd integrate the function between b and a, wouldn't we? And that would find the exact value of this area. But what if the function is really complicated and we're not quite sure how to integrate it? Well, we can use an approximation called the trapezium rule, which is given in the formula book. Now, as it's named, the trapezium rule, it's obviously related to trapezia. Now, if I wanted to split this into some trapezia like that, that's not going to give me a very accurate representation of the area, is it? But that will. Okay, so the more trapezia, the more accurate the area will be. Quite similar to what you may have been doing at GCSE maths. So let's have a look at how this is actually used. So this is a typical exam question. In fact, you'll often find in your exam your function is something that you can actually integrate. It's just asking you if you can use the trapezium rule to find an approximation. So the first thing we've been asked to do is we've been asked to fill in the table correctly, so filling in the blanks. Now, I'm going to be honest with you guys, if you lose marks on this, you might as well quit now. This is substituting straight into this function and writing down what your calculator says. Every single person can do that. So, if I was to substitute in x equals 2 into x ln x, I will get 1.386 to 3 decimal places. If I substitute in 2.5 into this, I will get 2.291 to 3 decimal places. Okay, so now we're going to have a look at how to actually use the trapezium rule, and in particular what this value of h actually means, which looks rather complicated at this moment in time. So, just need to make a quick note of what we actually got from the previous one. So that's 1.386 and 2.291. Okay, so the trapezium rule is 1/2 of this thing h, and then we're going to take the first value and the last value, and then we're going to take 2 lots of every other value. Okay, and that is going to give us an approximation for that area. Now, as I said before, if we wanted to check this, we could actually integrate this between 4 and 1, and we will get very close to this answer here. The only thing that's left for us to do is figure out what this h thing means. Now, in essence, it's if we take the upper limit, subtract the lower limit, and divide by how many trapezia there are, then that is what h is. However, it's much quicker and much easier to actually say it is the even gap. Okay, it's always split into even trapezia, and that gap in the x-axis is what h is. And you can do that by saying 4 subtract 1 is 3, and there are 6 trapezia. There would be 6 trapezia if you were to draw them in here. So 3 divided by 6 is 1/2. It's always the same as the gap in x. So I'll plot that in there, and then I very carefully put this into my calculator, and what I in fact get is 7.36925 ... and it says to 2 decimal places 7.37 units squared to 2 decimal places. And that's it. Part C, part D could be find the exact value, in which case we'd have to integrate that by parts, substitute in the values, use log laws and things like that, and then it might ask you for a percentage error. Okay, so you work out the percentage change in the approximated value to the exact value. And that's the trapezium rule. Nice easy marks. Okay, so again, by watching this video, it doesn't instantly mean you'll be able to do it. Practice is the key to success, and the more the practice you do, the better you will become. And of course, amateurs call it genius, masters call it practice.